Oceanographers have a saying that makes most people stop and recalibrate their assumptions about the planet they live on. We have mapped the surface of the Moon and Mars in more precise detail than much of Earth's deep ocean floor. That is not a rhetorical device. It is a measurable fact, quantifiable in resolution per square kilometer, and nowhere is it more consequential than in the Bismarck Sea, a body of water north of Papua New Guinea whose floor is so complex, so deep in places, and so rarely surveyed that when a volcano began erupting there on May 8, 2026, the existing ocean charts could not accurately describe where the eruption was coming from or how deep its vent actually sat. The eruption was found by satellites. The seafloor maps were wrong, and the question that NASA's chief scientist at Goddard Space Flight Center has been asking since May is whether, for the first time in decades, the world is about to watch a new island emerge from the sea. The sequence began on the morning of May 8, 2026, when seismometers registered a swarm of small to medium earthquakes beneath the central Bismarck Sea. Within 24 hours of those initial tremors, NASA's satellites detected the signature of an active submarine volcanic eruption. Areas of discolored water, thermal hotspots visible in infrared imagery, and a white plume of steam rising from the sea surface. By May 11th, 3 days after the eruption was first detected, Landsat 9 was imaging closely spaced volcanic plumes streaming from what the false color thermal data identified as a growing underwater volcanic platform. The eruption was not a single vent. It appeared to be spreading along a structure that scientists believe is part of Titan Ridge, a poorly understood submarine volcanic feature located approximately 16 kilometers southeast of where a previous underwater eruption occurred in 1972. The bathymetry, the seafloor depth maps, for this region had suggested water depths of several hundred meters or more above the erupting structure. Simon Karn, a volcanologist at Michigan Technological University who analyzed the satellite thermal data, drew a different conclusion. There must be a lot of hot material near the surface to generate so many thermal anomalies, Karn said. This suggests a fairly shallow eruption vent, much shallower than what's implied by the existing bathymetry. The chart said the water was deep. The thermal signatures said something close to the surface was generating enough heat to be detected from orbit. The satellite caught the volcano before the maps knew there was a volcano to catch. To understand why this matters, you have to understand what the Bismarck Sea actually is and why its floor remains so poorly known. The Bismarck Sea is a semi-enclosed body of water bounded by Papua New Guinea to the south, the Bismarck Archipelago to the north and east, and the Solomon Sea to the southeast. Geologically, it is one of the most complex regions on Earth's surface. The region contains active subduction zones where tectonic plates are diving beneath each other, spreading centers where new seafloor is being created, rifts, volcanic structures, and fault systems that intersect and interact at depths that make detailed survey work extremely difficult. The tectonic environment here is the product of millions of years of Pacific plate motion, and the result is a geological patchwork that has not been systematically mapped at the resolution applied to more accessible and more strategically important ocean regions. The consequence of that knowledge gap becomes apparent whenever something unexpected happens on the Bismarck Sea floor. In the present case, what happened is that a volcano began erupting at a depth shallower than any existing map indicated was geologically probable in that location. The satellite thermal data revealed the error, not because satellites are more accurate than sonar surveys, but because satellites were looking while sonar surveys had not. The Bismarck Sea floor will be better mapped after this eruption than it was before it, because a volcano provided the signal that triggered the attention. As the eruption continued through May and into June, the satellite imagery documented a rapidly evolving scene. NASA's Terra satellite MODIS instrument captured wide-area views showing floating pumice, buoyant volcanic rock fragments created when gas-rich lava cools rapidly in water, trapping bubbles that keep the material afloat, spreading southwest from the eruption site across a progressively larger area of the Bismarck Sea. Steam plumes from the eruption reached 10,000 feet above sea level. Infrared thermal signatures showed multiple hotspots distributed across a wide area, consistent with an eruption occurring along an extended fissure rather than from a single point source, and the pumice rafts continued to grow. Pumice from submarine eruptions is not a benign byproduct. Individual pieces look like gray sponge and float because their internal structure is honeycombed with gas bubbles locked in place by rapid cooling. In enormous quantities, millions of tons of material released by a submarine eruption. They accumulate into rafts that can cover hundreds of square kilometers of ocean surface and persist for months to years as ocean currents carry them across wide distances. They block sunlight from reaching marine life below the surface. They damage coral reefs. Fish mistake pumice fragments for food. Marine vessels have difficulty navigating through dense rafts. And when those rafts drift toward inhabited coastlines, the consequences are immediate. By early June, the pumice from the Bismarck Sea eruption had drifted northwest and begun accumulating along the coastlines of Papua New Guinea's Admiralty Islands. Manus Island, whose communities depend on the sea for food, transport, and economic activity, was among the first to be severely affected. Pumice accumulated along coastlines in layers meters thick. Fishing boats could not clear the rafts to reach open water. Coastal access by small vessels became impossible in some locations. Radio New Zealand reported residents describing the situation in direct terms. This is a disaster. Papua New Guinea's National Disaster Center issued advisories for affected coastal communities. Local tsunami concerns, triggered by the eruption's seismic signals, prompted official warnings that were later assessed as precautionary. Jim Garvin, the chief scientist at NASA's Goddard Space Flight Center and a researcher who has studied submarine volcanic eruptions, including the 2022 Hunga Tonga Hunga Ha'apai event, has been closely following the Bismarck Sea eruption since its detection. "We're now eagerly waiting to see if a new island is about to be born," Garvin said, "something that we've only rarely been able to observe with satellites as it happens." The scenario he is watching for, as the erupting material accumulates and the volcanic platform builds upward toward the sea surface, it may eventually break through, creating a new landmass in open water. This is not unprecedented. The Hunga Tonga volcanic system produced a new island in the 2014 to 2015 eruption that was subsequently eroded and then rebuilt in the 2022 eruption before the collapse that generated one of the most powerful volcanic tsunamis ever recorded. The Bismarck Sea event is smaller and occurring in a less structurally connected location, but the thermal signatures and the shallowness of the vent suggest it is close enough to the surface that island formation is within the range of physically plausible outcomes. To produce a new island, the erupting material must pile up high enough to exceed the sea surface. Submarine eruptions typically build platforms of fragmented volcanic rock and lava that are constantly being partially eroded and transported away by water currents even as they grow. Whether any given eruption breaks through depends on the balance between the rate of material output and the rate of erosion and dispersal. In the 2026 Bismarck Sea eruption, the extended duration and the multiple thermal hotspot signatures visible from space suggest a sustained output rate that has been sufficient to maintain the eruption at shallow depths for more than 2 months. What it has not yet done, as of this broadcast, is break the surface. When, and if it does, scientists will have the opportunity that Jim Garvin described, watching a new piece of Earth form from nothing in real time with satellite resolution sufficient to document the process day by day. They could then track how rainfall, wave action, and biological colonization transform the new volcanic surface. The same set of observations made after the 2014 to 2015 Hunga Tonga Island appeared. That island persisted for approximately 5 years before being eroded, providing an unexpected natural laboratory for studying how ocean systems respond to new volcanic land. A Bismarck Sea island, if it forms, would offer a similar opportunity in a very different geological context. The Bismarck Sea's communities are not waiting for a new island to form. They are dealing with the pumice that is already there, on their coastlines, in their fishing grounds, blocking the water access that sustains their daily lives. The broader Pacific pumice dispersal, visible in satellite imagery as a progressively expanding field of debris drifting on ocean currents, will carry some of this material thousands of kilometers over the coming months, potentially affecting coral reefs and marine ecosystems across a wide region before it eventually absorbs water, becomes too heavy to float, and sinks to the seafloor to become part of the geological record. There are 3 things scientists are watching in the weeks ahead. The first is whether the eruption reaches the sea surface and produces visible new land. The thermal data and the evidence for shallow vents make this a meaningful possibility, and the satellite monitoring cadence is now calibrated to detect the emergence of new surface material as quickly as it appears. The second is the extent and trajectory of the pumice rafts. Current satellite tracking shows the rafts spreading northwest into the Bismarck Archipelago and Admiralty Islands region. As the eruption continues and ocean currents carry the material further, the affected area will expand. The economic and ecological impact on fishing communities will depend directly on where those currents take the pumice and how long it persists. The third is the bathymetric update. The eruption has revealed that the existing ocean floor maps in this region are inaccurate in ways that matter for understanding the area's geological structure. Every piece of satellite data, every sonar measurement taken by research vessels, and every seismic signal from the continuing activity is contributing to a revised picture of what the Bismarck seafloor actually looks like. The volcano that nobody had mapped is, in the process of erupting, providing the data needed to map it. We have better maps of Mars than of the ocean that just did this. The eruption started in May. It is still going. Subscribe to stay ahead of what's coming.